Hello again, ladies and gentlemen. Mr. Donahue here again, taking a look at 5.7b stuff, heat of formation problems. So our objectives will be to use the delta HF, so the heat of formations of the compounds in a reaction, to determine the delta H for the reaction. So you've learned what the heat of formations are. You've learned about Hess's law. What we're going to do now is we're going to combine them. We're going to use them together to solve some delta H kind of problems. All right, so let's say this was my desired reaction, right? I got C3H8 gas reacting with 5O2 gas, giving me 3CO2 and 4H2O. Well, Hess's law, we can use these reactions with known enthalpies to determine the enthalpy of an overall reaction. So the heat of formation, being the enthalpies for the creation of a compound from its constituent elements, we can use those as the reactions to give us the overall reaction. Right, so we can use the heat of formations for each of these compounds. Or, what's the heat of formation for C3H8? You just look it up. For O2, it's going to be 0. You're going to look up CO2, and you're going to look up H2O, and you're going to use those values and those reactions to figure out the whole reaction overall. So I'm going to show you two ways. We're going to take a look at the long way first, and then I'll show you the quick way. So what's the long way, you're probably asking? Well, the long way is to write out the reaction equations for the heat of formation for each compound's present, and do like what we've done for the Hess's law. Then it's the same thing, okay? So let's do this the long way. We go, all right, well, some compounds that I'm making, I've got to make H2O. So I write the heat of formation reaction for making H2O, and I look up its value. So I do the same thing for all of these things. I look up for CO2. What's the heat of formation for CO2? Write out that equation and the delta H. O2 is not going to have one because it's just an element, so it's, you don't got to worry about that. And then look up C3H8 and write its equation, right? So if I'm making C3H8, I need 3 carbons and I need 4 H2s. And then I look up its value. It's right there. So now I'm going to do like what we did for Hess's law. You're going to figure out what you got to do these equations to give you the overall equation. So, well, let's see. I need H2O as a product. And I found it right here as a product, but I need 4 of them. So what I'm going to have to do to this is I'm going to have to times it by 4, right? So I times all this by 4. I get 4 H2s. I get a total of 2 O2s, and I get 4 H2Os. All right, well, what about this CO2? Well, it's in this equation as a product, and that's how I need it, but I need 3 of them. So I got to times this by 3. So I times this equation, whole thing, by 3. I get 3 carbons and 3 O2s, giving me 3 CO2s. Now, what about this C3H8? I need it as a reactant, and in this equation it's a product, so I'm going to have to flip it. So I'm going to have to change the sign on this from negative to positive, right? So let me rewrite that out so I can, sum them all together. I get C3H8 giving me 3C and 4H2. So now hopefully, if I've done this right, everything will cancel out except for what's in this equation. So let's see. I got H2 in this equation, but no H2 in my reactions. Hopefully I see H2 somewhere else. Hey, look, 4H2, 4H2. They're going to cancel out because they're on opposite sides. One's on the reactant, the other's on a product. Well, let's see what else. Let's see. Water, H2O. I got 4 H2O right here, and I have no H2O anywhere else. So that's going to come down to the bottom. So I end up with 4 H2O. And what about carbons? I got 3 carbons here, and I got 3 carbons here, so they're going to cancel out. So they're not going anywhere. Oxygens. Well, I have 3 oxygens here. I got 2 oxygens there, and I don't have oxygens anywhere else. So I'm going to end up with 5 oxygens on the reactant side. So far, so good. And let's see. I got 3 CO2, and there's no CO2 anywhere else. So I end up with 3 CO2. And let's see, this equation, I got C3H8, and that's the only place it is, C3H8, and I'm out of everything. And hey, look, I got the desired reaction. So all you got to do now is sum up all this. You go, all right, well, the delta H overall is going to equal that negative 285.8 times 4, and then you're going to add that to the negative 393.5 times by 3, and then you're going to add that to the positive 103.85 kilojoules. And when you add all them together, you're going to get the answer of a negative 2219.85 kilojoules. So that's how you do that. That's the long way. And I hope you see why it's the long way. It's kind of obnoxious, okay? So why don't I show you the short way? The short way is to just write the heat of formations under the appropriate compound. So you look up like what's the delta HF for this compound and then just write the number below it, okay? Then you're going to account for the coefficients in front of them. So like if I had the delta H of formation for CO2, well, I'm going to have to times that by 3 because I got a coefficient in front of them, right? So you're going to do that for everything. Like I said, yeah, if you had a delta H formation for H2O, it's negative 285.8 kilojoules, and you got 4 of them, then you got to multiply that number by 4, right? So yeah, okay. And then you're just going to sum up all the enthalpies on each side. So you're going to use that arrow, and you're going to go, all right, what is the total over here, and what is the total over there? And then to get the delta H, all you do is you take the difference. You know, sum of the products minus sum of the reactants. How did it change? That's the delta H. And if you ever get confused about the sign, a good way to check to make sure you got the right sign, if it's positive or negative, look at the values. You know, was there an overall increase in enthalpy? Because that'll be a positive delta H. Or was there an overall decrease in enthalpy going from reactants to products? Because if it's a decrease, then it's a negative delta H. So let's do this, okay? So you're going to look up these values. You would just get this from a chart, right? You just look them up in a chart, and then you got them. So you write them down, or they're given to you in the problem. And then you go, all right, well, let me write underneath. Let me look up C3H8. And I see C3H8 is a negative 103.85 kilojoules. And the coefficient is 1, so I don't have to do anything to that number. The coefficient or formation of oxygen, because it's a pure element and its standard state is just 0, so I don't have to worry about that. And then I got to look up, well, what's CO2's? I look it up. It's negative 393.5. And I'm going to have to times that by 3 because there's 3 CO2s. So now I look up waters as a liquid, and it's negative 285.8, and I'm going to have to times that by 4 because there's 4 of them. So now I'm going to combine these numbers together on each side of the equation. Reactant side is real easy. I get negative 103.85 kilojoules. And then it goes to, let me add those numbers quick together, negative 2323.7 kilojoules. So now if we want to know what the overall change is, well, we got to look at what the products are minus the reactants, right? So we're going to go, all right, negative 2323.7 minus a negative 103.85, and I'm going to get the answer. Hopefully the same answer that I got above. I get negative 2219.85 kilojoules. So that's going to be my final answer. Now, what I was saying earlier, you know, is it a positive or a negative value? If you ever get confused, think about this. All right, I have a negative 100-ish, and I end up at negative 2,000-ish. So it went even more negative. So that's going to be a negative value. And then, hey, look, I got a negative value for my answer. Perfect. Okay? So summarize, all right? How can heats of formation be used to determine the delta H of a reaction? That's what this whole thing was, right? So that's really all you need to be able to summarize. Can you do that? If not, that's a problem. If you can, awesome. Bring questions. I'll see you in class. Okay, bye.